Live. Cool guys. Hi. Yes. So let me start the share screen. So guys, yeah, in today's class we'll be discussing about the basics of whatever we learned in our previous class. So let's have a quick. Okay, before revision, I think we have few questions to solve. ಏನೋ ಅಂಕಲ್ ಏನೋ ಬರುತ್ತಲ್ಲಪ್ಪ ದೇವರೇ. Okay, so I think we had stopped here in our previous class, guys. Yes. Um so before we start the class, I want you guys to give me the technical check. So please go through the technical check check if my voice is visible. I mean, if my voice is audible clearly and my board is visible clearly. Okay. Cool, guys. Superb. So please, guys, come on, try to give your polls for technical check. Let me know if my voice is audible clearly and the blackboard is visible clearly. Hi, guys. Hello. Hope everyone is attentive now. Okay, I think I had given you a homework in my previous class. So did you guys check that? Did you guys check the homework? Hello, guys. Let me know in the chat box if my voice is audible, guys. Please come on. Tell me, everyone. I don't know. I'm not able to access. I mean, my network is very slow here, so I'm unable to differentiate or I'm unable to check if somebody is able to check my voice. Yes, please someone try to yes clear. Cool. Is the poll launched to you guys? Please confirm that. Anusha, confirm ಮಾಡಿ poll launch ಆಗಿದೆಯಾ? Yes. Please try to give an vote in the poll. I'm unable to see if anyone have given the yes. Okay. Thank you, Rakesh. So, are you guys trying to give answer the poll, guys? I don't know. I'm not able to see the response. I'm unable to see the response. So, what I'll do, I'll just end this poll and relaunch another poll. I think that would be good. So I think now the poll is launched again, guys. Come on, try to answer the poll. Is my voice audible clearly? Everyone, please try to answer. Is my voice audible clearly and the screen visible clearly? Tell me if the poll has yes. Thank you, Rakesh. So please try to answer in that. Okay, cool, guys. Chalo, if you are able to hear my voice clearly and if you are able to see the board clearly, then that's great. But I don't know why this thing I'm unable to see exactly what's happening. Uh, so yeah, so in our previous class we had discussed about. So I'm going to end the poll. Hope everyone, guys, please let me know at any point if my voice is not audible or if the screen is not visible. Please let me know. Okay. So hope everyone is able to see. Please click on yes if you are able to hear my voice clearly and see the board clearly. Please click on yes, guys. You have to respond. Please click on yes. Participants, go to the participants option. You will get yes, no, go slow, go faster, etc. So please click on yes on that, guys. Yes. Okay. Cool. 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 Then yeah. Yes. So I got the confirmation that my voice is audible and the screen is visible. So in our previous class we had studied about the parallel plate capacitor, right? So in today's class we will have some questions on parallel plate capacitors. Then yeah. Once we have done the questions on parallel plate capacitor, we'll try to revise all the concepts which we have studied so far. Then Yeah, we'll move on to the next part, that is the energy stored in the plates of capacitor, then the energy density, then the combinations of capacitor in today's class. Okay, so hi YouTubers, good afternoon. Good afternoon, Krish Modi, Bhargav, Raj Lakshmi, Priyanka. Hi. So guys, I think I had given you a homework regarding this. So for this capacitance, the rated capacitor was 2.25 microfarad, whereas on calculation, how much did you get? You get somewhere around 1 microfarad. On calculating, you get the value as 1 microfarad. If you try to substitute all the values, you will get approximately 1 microfarad. Now, why is there a difference between this rated value and the calculated value? Guys, why do you think there is some difference between the rated value and the calculated value? Yes, because, come on, try to answer, guys. Why do you think? Come on, guys. Hello. Why do you think there exists a difference in this capacitance when we calculate the area wise? So we know that C is equals to epsilon naught A by D, right? Epsilon naught A by D. So if C is equals to epsilon naught A by D, then by substituting the value of my A and D, I would get the capacitance approximately 1 microfarad, right? So if my capacitance is 1 microfarad, then if the rated value, see, they'll mention the value, the rated value is 2.25 microfarad. Why is this happening? Okay, so the reason is also mentioned here, the dielectrics introduced. So here the dielectric is nothing but my plastic, which is present, right? So this plastic, yes, this plastic is a dielectric which increases the capacitance. So the dielectric medium stores all the charges in it. So we'll study how the dielectric medium stores the charge, what happens in today's class. Okay, so how capacitor works, etc. in today's class. So yeah, let's start with the recall test. So I have a recall test. Say a capacitor of capacitance C is charged to a potential. Guys, come on, try to answer this. A capacitor of capacitance C is charged to a potential V. The flux of the electric field through a closed surface enclosing the capacitor is. What is the flux, guys? Come on, tell me. What do you think the flux is? Value of flux. Yes, correct. Exactly, Prajwal. Superb. So, guys, try to answer the MCQ which I have launched. I hope MCQ is launched. Guys, let me know if the MCQ is launched. Don't know why there is some lag or delay in the connection. So there has been some significant delay. Yes, exactly, Rakesh. Correct. So, guys, if you are not able to answer in the polls, please answer in the chat box. Okay. So, failed to launch poll. Okay. So, yeah. So, guys, I think I have launched a poll. I had launched the poll, but it was failed. So I have launched it again. So please check that. Bro, I don't know why I'm unable to make you the co-host. I'm trying to click, but it's not getting. Yes, guys, come on, try to answer the poll, guys. So, okay. So, guys, if I don't know why I'm not able to read the polls too, please reply in your chat box, guys. Please reply the answers in your chat box. So Krishmodi, no, check your answer. Bhargav, check your answer. Ramakrishna Reddy, check your answer. I'm asking about the what? I'm asking about the flux, not the field. Okay. Okay. No, I'm asking about the flux, not the field. So the flux of the electric field through a closed surface enclosing the capacitor is what? So guys, it's just the application of Gauss's law. No, Prajwal, check your answer. Dhanush, check your answer. Abhishek, check your answer. Come on, guys, try to answer fast. So I got only one correct answer so far, guys. No, they just check your answer. Guys, please try to answer in the polls once. Okay, guys, so I'm going to end the poll. I don't know why it's not recording any answers. So, yeah. Okay, the answer is option D, guys. So, option D is the right answer for this question. So, sorry, I couldn't read any of your answers. Option D is the correct answer. Why? So, what is Gauss's law, guys? We had studied Gauss law. What is Gauss law? What does Gauss law say? The flux is nothing but the total amount of electric field enclosed inside a closed surface, dA, inside a Gaussian surface. So the total flux is, the net flux is nothing but the entire electric field enclosed, entire electric field inside a closed surface, right? Say if I consider a capacitor, say inside this closed surface, how much, say in one end I have all positive charges in the inside the inner surface. In the other end, in the other plate, I have all negative charges in the inner surface. So now, what is the net electric field inside this? What is my net electric field, E net? How much is my E net, net electric field? Guys, please reply in the chat box. Yes, flux is equals to, yeah, this is nothing but Q enclosed on epsilon naught this also. So this is by Gauss law, this is by general expression. Flux is nothing but closed integral of E dot dA. So here, what is my net electric field? Yes, right. So we know that both the plates have opposite charges. Say one plate is charged with plus Q charge, one plate is charged with plus Q, other plate is minus Q. Now we know Q is nothing but what is my Q, guys? What is my Q? Q is C into V. Can I say this? Q is C into V. So what is the net charge enclosed inside my Gaussian surface? Net charge Q net inside the Gaussian surface, or Q enclosed inside the Gaussian surface. Say I know Q is equal to C into V. Can I apply this to find the charge, total charge on each of the plates? Yes, no. Yes, correct, Bhargav. Correct, Ramakrishna Reddy. Yes, correct, Abhishek. So my plus Q will be have plus CV, and my minus Q will be having minus Q is equals to minus CV. So my Q net, what will be my Q net? Is nothing but plus Q minus Q. So this will be plus CV minus CV. So this will be equal to 0, right? My Q enclosed will be equal to 0. If my Q enclosed itself is 0, what is my flux? Flux will also be 0, right? Right? So I hope everyone have understood why this is 0. So the flux through the electric field, the flux of the electric field through a closed surface is enclosing the capacitor is always 0, okay? So there won't be any flux. Got it, guys? Please click on yes if you have understood. Exactly, Krishmodi. Guys, please click on yes if you have understood. Any doubts in this? Okay, cool. Thank you. So next, the capacitance of a parallel plate capacitor depends upon. So I'll relaunch the poll, guys. I don't know if that works. Yeah, please answer the poll if the poll is working. If the poll is not working, please answer in the text chat box. Okay, everyone. So guys, please try to answer this question. So this will just help me to understand how much you have understood in all the previous concepts. Okay. Come on, guys, try to answer this. So the capacitance of a parallel plate capacitor does not depend on. Dhanush, check your answer. Please check your answer, Dhanush. So it's the basic property of capacitance. So the question is it's given in a twisted way. Say the proper way of question might be, if I want to ask the direct question, so what are the factors which the capacitance of a capacitor depends on? If you try to answer that, you will get the answer. Abhishek, check your answer again. No, Tejas, check your answer again. Chinmay, check your answer. So guys, tell me one thing. So what are the factors? Yes, Amit, exactly correct. Amit is Rakesh correct. Amit correct. So what are the factors my capacitance depends on? What are the factors my capacitance depend on? Tell me this answer, you will get the answer directly. What are the factors which my capacitance of the capacitor depends on? So yes, correct. Density. So give me the example, guys. So sorry, give me the expression. C is equals to. I know we had studied two types of capacitor so far. One is spherical conductor capacitor, other is parallel plate capacitor, right? So what was the capacitance of a single body conductor? Say for a spherical case, spherical conductor case, what was the capacitance? C is equals to C is equals to 4 pi epsilon naught into R, right? And again, what was my C in case of parallel plate capacitor? C is nothing but epsilon naught A by D. In this both expressions, in this both expressions, I can say easily that the capacitance of any capacitor depends only on the geometrical properties like the radius here, like area and distance here. In this case, it's area and distance. So if you see it, in the capacitance in this case, spherical conductor case, it depends on the radius. In this case, it depends on the parallel area of the plates and the distance separation distance between the plates. So and also here again, so for the plane condition, say for a parallel plate condition, we also learned that it depends on surface charge density, right? My charge, I mean the capacitor depends on the surface charge density of the plates, right? So if you consider all these things, the capacitance of the any capacitor depends on surface charge density, size of the plates, and separation distance. What does not it depend on? It does not depend on the charge on the plates, right? So which is the correct answer, guys? Come on, tell me which is the correct answer. So the capacitance of the capacitor does not depend on the charge of the plates. Okay, understood? Yes. Hope everyone understood this. Yes, Dhanush. Correct, right? It depends. See, okay, Dhanush. So we'll consider that also. We know that Q is equal, C is equals to Q by V, right? Q by V. In this case, acha. So if you go by this expression, this is a general expression. But for any other capacitance, say they have mentioned the parallel plate capacitor in the question. So this is for general question, right, Dhanush? अर्थ ಆಗ್ತಿದ್ಯಾ Dhanush? So this is the expression C is equals to Q by V for any general capacitance. But here in the question they have mentioned the parallel plate capacitor in specific. So for that, what are the factors my capacitor depends on? The capacitance of capacitor depends on. So for parallel plate capacitor condition, my capacitance depends on surface charge density, area, and the separation distance. ಅರ್ಥ ಆಗಿದ್ಯಾ? I hope everyone have got this. Density of the plates is surface charge density, right? Density on the plates means surface charge density. So guys, okay, some people are asking to explain again. So see guys, in this question they have given in specific the capacitance of a parallel plate capacitor. So what are the factors my parallel plate capacitor depends on? See, the parallel plate capacitor depends on the capacitance of my parallel plate capacitor depends on the area or the size of the plates. Yes, it depends on size of plates. Second, it depends on the separation between the plates. Yes, and the density of the plates means that's nothing but surface charge density. Okay, here density of the plate means surface charge density of the plate. So it depends on the surface charge density of the plate also. Otherwise, we know C is equals to epsilon naught A by D. So with this, we can say my capacitance does not depend on charge at all, right? So The capacitance of a parallel plate capacitor does not depend on charge of the plates. Okay, this is the only incorrect one. I hope now, I guess everyone have understood this. Any doubts, guys? Let me know. Bhargav, hope you got it. Dhanush, I hope you got it. Others, please reply if you have got this. Guys, yes, please try to reply. Click on it if you have got this. Any doubts in this, please let me know. Guys, we have, yeah, cool. So Dhanush, please give me the confirmation. Bhargav, Ratnala, please give me the confirmation if you have understood. Yes, so Hari Prasad, yeah, they have given only the mentioned only the parallel plate capacitor. I took just spherical controller as an example. Okay, cool. Dhanush, please give me. I want confirmation from you if you have understood, and if you have any doubts, please ask. Okay, cool, cool, clear. Okay, next question, guys. So when at 1 into 10 power minus 2, so guys, I don't know why I have launched the poll, but if you have got the poll, please answer in the poll. Okay. So the question is, when 1 into 10 power minus 12, uh, Hari Prasad, for your doubt, Hari Prasad. So the size means the area, Hari Prasad, area of the capacitance, sorry, area of the parallel plates of that uh, parallel plate capacitor. Size means size of the plate is directly nothing but the area of the plates. Okay, don't get confused, guys. Come on. So we have come to the next question. So the next question says, when 1 into 10 power 12 electrons are transferred from one conductor to another, a potential difference of 10 volts appears between the conductors. Calculate the capacitance between the, okay, calculate the capacitance of the two conductor system. Come on, guys, try to answer this. I don't know if I don't know. The poll is not working, guys. Please try to answer in the chat box. Everyone, please try to answer in the chat box. Yes, correct, Dhanush. Dhanush, correct answer. Dhanush, please confirm if you have understood the previous question. Yes, Tejas, correct answer. Okay, cool. Thank you, Dhanush. So others, please try to answer, guys. Come on. I don't know. The poll is not working. Please, I'll again try to relaunch the poll. If the poll is working, it's fine. Try to answer in the poll. Otherwise, please, yes, bro, please try to launch. Correct, Amit. Amit, correct answer. Others, guys, come on, try to answer. So, how to solve this question, guys? Come on, tell me how to solve this question. So, if you see this question, they have mentioned transferring of 1 into 10 power plus 12 electrons. So, we are transferring 1 into 10 power plus 12 electrons from one conductor to another. So, from one conductor to another conductor, I'm transferring. So if I have connected such thing, say I'm transferring 1 into 10 power plus 12 electrons. Okay. So after transferring, say the plates have 1 into 10 power plus 12 electrons each. Now the potential, potential it gets as 10 volts. So what is the charge on this conductor? So calculate, say first you have to find what are the individual charges on this conductor. Say if I have plus and minus charges, find out how much charge is on this conductor. Yes, correct, Bhargav, exactly. So if the number of electrons, say they have given the number of electrons. So if you know the number of electrons, how to find the charge? So if you know the electrons, how to find the charge? If you get the charge, you can directly apply C is equals to Q by V. Okay. So first, how to find the charge, guys? Come on, tell me. Exactly, Bhargav. Guys here, please try to answer. Mhm. No, Dhanush, ಆತರ ಆಗಲ್ಲ. So Q is equals to N into E. Exactly, Abhishek. Super. Correct. Correct. So we know that Q is equals to number of electrons, number of electrons into the charge on one electron. So if you try to find out the Q, that is 10^12 into 1.6 into 10 power minus 19 coulombs. So how much is the charge? Guys, tell me how much is the charge? ಹೇಳಿ ಎಷ್ಟಿದೆ ಚಾರ್ಜು? Come on, guys. Yes, exactly, Chinmay. Correct answer. So my charge would be 1.6 into 10 power minus 7 coulomb. Okay. So if my charge is this much, say then how much will be my capacitance? So that will be 1.6 into 10 power minus 7 divided by 10. That is 1.6 into 10 power minus 8 farads. So this is my capacitance. Exact. Correct, Devika Rani. Cool. Okay, guys. So hope everyone have understood this question. Yes, correct, Rajwal. Yes, guys. Correct, correct. So hope everyone have got this question. Yes. Please click on yes. Guys, since I don't have any other modes of communication, please try to answer with the non-verbal communication chats. So I request everyone to click on yes, no, or yeah, yes or no for now. So if you have understood, please click on yes. If you have any doubts, please click on no and ask your doubt. Okay, cool. Thank you. Come on, guys. So we'll go to next question. So next question is the plates of a parallel plate capacitor are made of circular discs. So the plates of a parallel plate capacitor is made of circular disc. So there are two circular discs of radius 5 centimeter. So the circular disc has a radius of 5 centimeter each. If the separation between them, say if they are separated by a distance of 1 millimeter, how much is the capacitance? So how much is the capacitance? Guys, come on, try to answer. Uh, so hope everyone, if your poll is, guys, I have launched the poll. If you are able to see the poll, please check, give the answer. Otherwise, please try to answer in the chat box. Okay, YouTubers, please try to answer this question. Come on, guys, come on, come on. Yes, Yojita, that was correct answer for the previous question. Correct. Krish Modi, correct. Vargo, correct. Devika Rani, correct. Okay, others, please try to answer this, guys. Come on. So what are they asking? So they have given us two discs. So what is the formula we use, guys? Please come on, try to be active, guys. Come on, come on. Try to be active. Guys, be active, be active. So expression helipa. No. So what is the expression for capacitance of this? So is it a parallel plate capacitor? Yes, they have mentioned it's a parallel plate capacitor, right? What is the expression? We know that C is equals to epsilon naught A by D. So if that's the thing, so please try to simplify that. Just substitute the values of epsilon naught A and D, then you will get the answer. Okay. So what is the area, guys? Correct, Krishmodi. What is the area in this case, guys? Yojita Reddy, correct. Yes, Abhishek, check your answer. Rakesh, check your answer. Okay, guys, please give the magnitude at least. Okay, so please give the magnitude. So I have to multiply 10 power minus 5 to each. Yes. Now I think you might get the answer. Come on, guys, try to give the answer. Yes, Danush, correct answer. Abhishek, check that again. I think you are close to the answer. Rakesh, even you are close to the answer. Please check that. Yojita Krishnamoji, correct. Danush, correct. So, guys, Abhishek, correct. Yes, exactly. Abhishek, super. Rakesh, others, guys, come on, try to answer. So, there are only very few students answering always. I want everyone to answer. Please try to answer, guys. At least respond me if you are able to get all the answers. So see, we'll try to calculate. Okay, C is equals to epsilon A by D. Epsilon naught A by D. Epsilon naught is 8.854 into 10 power minus 12. So what is the area of this circular disk, guys? What is the area of a circle or a circular disk? A is equals to area of a circular disk is pi r square. Can I call this? It's pi r square. Yes. So area will be nothing but pi into 5 square. So this is nothing but 25 pi. Yeah. Yes. So we'll put all the values now. My C is equals to epsilon A by D. So epsilon A is nothing but 25 pi divided by my D is 1 into 10 power minus 3 meters. So if I try to simplify, what would I get? C is equals to, so 8.854 into 25 into 3.14. How much is that? 8.854 into 25 into 3.14 is 695. So in the numerator, I'll get 695.03 into 10 power minus 12. In denominator, I'll get 10 power minus 3. If I try to simplify, I'll get C is nothing but, yes, 12 minus 5. Yes, 695 into 10 power 7. Okay. So if I try to simplify further, I'll get C is nothing but 6.95 into 10 power minus 5 into 10 power minus 6 farad. So, yeah. So that is nothing but 6.95 into 10 power minus 5 microfarad. Okay. So this is the answer. So option A is the correct answer, guys. Come on. So hope everyone have got this or have understood this. Yes, convert to meter. Okay. So yeah, exactly. So that is 10 power minus 4, right? I had missed this power 10 power into 10 power minus 4. Numerator, I have one more power, that is 10 power minus 4. So we get something similar to this. Okay, guys. Hope everyone have tried to answer. I mean, everyone got this correct answer. Yes. Please click on it if you got this answer. Guys, there is some difficulty in checking your chat box also. Hope everyone have answered. I am unable to check your chat box. Maybe my internet is very slow here. Sorry for this. Okay. So next question, guys. So we'll go to the next question. So what do the field line in a finite parallel plate capacitors look like? So your question is how does the field of a finite parallel plate capacitor look like? Guys, please check your answer, Dhanush. Once, please check your answer. So ಎಲ್ಲ ಚೆಕ್ ಮಾಡಿ. See, try to find the most appropriate answer. Okay, try to find the most appropriate ones. Exactly, Rakesh, correct. Rakesh, correct answer. Dhanush, check your answer. Dhanush, I think we had mentioned that, right? The exact electric field representation of parallel plate capacitor would be. Amit, check your answer again. So, YouTubers, please try to answer, guys. Suchindra, check your answer. Amit, correct? Exactly, Amit. That's the right answer. Yes, most of you are getting confused there. Please check that. Okay. Raj Lakshmi, please check your answer. Yojita, check your answer. So try to find the appropriate answer, most appropriate answer. Bhargav, we are not neglecting the edge effects here. Okay. Okay, nice guys. So I'm getting the polls result now. Cool. So most of you had given me. Prajwal, check your answer, guys. Come on, guys. Please remember what I told in my previous class. So you have to recall what we have discussed now. Hariprasad, check your answer. We are not neglecting edge effect here. Okay, guys. So most of you had given me C, but no, that's not the right answer. The correct answer, the most appropriate answer is option B. Okay, option B is the right answer. Why? Okay, option B is the correct answer because see, if I consider, say, I told you the electric field lines are curved lines except at the center. Except at center, my electric field lines are curved. So here it's we are and not neglecting edge effects. Okay, I think in my previous class I discussed about the edge effects. So I told you how the edge effects are, and we should not neglect the edge effects always. But while derivation of parallel plate capacitor, expression for parallel plate capacitor, the edge effects were neglected. But here we are not going to neglect the edge effect. So my electric field lines are always curvish, okay, except in the middle. Say, what is the difference between B and C, guys? See, in B, we have some curved lines here too, but only in the middle part where my electric field is almost uniform. Yeah, only till this part, I have straight lines. After that, after four lines, we have slight curved lines, okay? So this will be my right answer, okay? Option B would be the right answer because realistically all the field lines have a finite curvature. Okay, please remember if you didn't know, in future you will be answering this. Okay, realistically all the field lines will have a finite curvature. Only the field lines which pass through the center of the plates is straight. Guys, please note this. This is very important. So there was a question based on this. I told you in my previous class also there was a question based on this. Okay, so option B will be the correct answer, and this is the proper correct representation of electric field. Okay, so guys, got this? Please reply. Yes, any doubts here? Guys, please reply. Please click on yes so that I can continue. Yes, no, ಹೇಳಿ please. Otherwise I can't, I mean I will be in a situation where I can't. So you told there will be no field in outer portion of the plates. Yes, Bhargav, that was well. Yeah. See, there will be electric field outside. See, if I did not say that, I think I mentioned while derivation only will neglect the edge effects. Otherwise, we won't neglect the edge effects. So we discussed that in our previous class also. So see, electric field exists only in the inner surface. We consider that by neglecting the edge effects. But I told without neglecting the edge effects, yes, there will be presence of electric field. So that is the representation. So Bhargav, we did not neglect the edge effect because they have not asked us to. So yes, electric field. So this is the correct representation of electric field, guys. Please remember. Okay. See, there will be electric field only at edges, guys. Okay, only at edges, and there will be electric field in this direction. Okay. So any doubts in this? So someone clicked on no. I'm unable to check this. My network is very slow. Yes, guys. Any doubts in this? Please reply in the chat box. I'll try to read the chat box. Yes, understood, guys. Anusha. Okay. Any doubts in this? Please ask. Yeah, I think I answered that, Ari Prasad. So we see. No, Ari Prasad. Option C is not most appropriate because see, please read this. Realistically, all the field lines are having a finite curvature. Okay. So everyone, please listen. So all the electric field lines, whenever we draw field lines, there will be having a finite curvature. All the electric field lines will have a finite curvature. Only the field lines which pass through the center. See, at the center, whatever the field lines we have, only at the center there will be straight lines. Okay, there will be straight lines only at the center. Otherwise, all other lines will be having a finite curvature. But while derivation of parallel plate capacitor, expression for parallel plate capacitor, we had considered that there are no there is no edge effect, so we did not consider the electric field lines outside the parallel plates. Okay, so that's the only reason. So I think I mentioned that the other day clearly. I had mentioned that very clearly, guys. So yes, we in our previous class we had learned about parallel plate capacitors and also the edge effects. We learned about the parallel plate capacitors. So what is the what is the expression for parallel plate capacitor? Capacitance of a parallel plate capacitor. It is C is equals to epsilon naught A by D, and it depends only on the area and distance of separation and also the surface charge density. We discussed that in our questions now, and also we got the expression, and yes, we had solved few problems in the previous class. Okay, so yes, in today's class, we'll be starting with energy stored in a capacitor. So to derive this expression, let us consider this. Okay. So guys, ready? Are you ready? Are you guys ready? Hope my voice is audible, guys. So I'm getting a message that internet unstable, unstable network. So is my voice clear, guys? Guys, please respond me. Is my voice clear? Okay, thank you, guys. Cool. So yeah, my screen is also visible, right? Okay, cool, guys. So here we have to calculate the energy stored inside a capacitor. So for this, we have to consider the two parallel plate capacitor. Now, initially, if there is one positive charge plate and a negative charge plate, what happens? What happens in this case, guys? Guys, your reply is very must. Say I had only two parallel plates. One is charged with positive charge and other one is charged with negative charge. What will happen in this case? What will happen in this case, guys? Come on, reply. Yes. So there exists an electric field and they start to attract each other, right? So say initially they were initially they were attractive. So what happens? The electric field from the positive charge, the electric field from the positive charge exerts a force. Okay, electric field which is emerging out from the positive charge, I mean for positively charged plate, exerts a force on negative charge plate, pulling the negative charge plate towards itself. Okay, so what is happening here? I have my positive charge plate exerting providing electric field, I mean generating electric field. It is going to attract, it's going to pull this electric negatively charged plate towards itself with a force F. Then this force F is given as F is equals to Q times of E. So in this case it is nothing but, so here my force is nothing but F is equals to Q times of E, right? So since it's attractive in nature, my force is negative. Hoda. So what is my electric field, guys, here? So the electric field by which it's attracting the other plate is given by E is equals to sigma by 2 epsilon naught. Okay, E is equals to sigma by 2 epsilon naught. Now what happens? The force on negative plate due to the electric field from positive plate. So what can this force be given as now? Using these two expressions, F is equals to Q into E and E is nothing but sigma by 2 epsilon naught. How can we give our force expression? So multiply these two, okay? On multiplying, say, or on substituting the value of E in this, I'll get the force acting on the plate. So guys, what I said, so initially there were two plates of the capacitor. One plate is charged with positive charge, other plate is charged with negative. Yes. Now the positive charge exhibits or it gives out some electric field. The positive charge gives out the electric field. There exists an electric field from positive charge to negative charge. This positive charged plate, what will it do? Pull. It will pull the negatively charged plate towards itself by exerting a force. That force is nothing but Q times of E. The force magnitude of force is given by F is equals to Q times of E. So if this is the force, if this is the force, and it is pulling towards itself, right? So it's always attractive in nature. The force is negative, the force will be negative. F is equals to minus times of QE. Now, this electric field on the positive charge plate, this is the electric field on the positive charge plate. Only on the positive charge plate is given by sigma by 2 epsilon naught, right? Now, the force on the negative plate due to the electric field from the positive plate is given as, so F is equals to minus of Q times of sigma by 2 epsilon naught. Okay. So with this force, my positive plate pulls the negative plate. Now what happens next? So can I keep this? Can I call this a capacitor if they are attracted to each other? Guys, please reply. So if they are attracted, if the both plates are attracted to each other, can I call that it's a capacitor? So there exists a capacitance if they are attracting in nature, like if they are together, like there's no separation, but there is one positively charged plate and there is one negative charged plate. There is no distance, no separation distance. Both the plates have stuck to each other, attracted to each other. Can I call this as a capacitor? No, right? I can't call it as a capacitor. So what I should do? I have to make us. I have to make such that have to make the two plates separated at least by separation of distance small d. So I have to put, okay, have to put some external force to pull these capacitors and keep them at a separation of distance d. Now we know that sigma is nothing but q by a. So if we substitute the value of sigma as q by a, we would get the force as, so F is equals to minus Q by 2 epsilon naught into Q by A, that is nothing but F is equals to minus Q square by 2 epsilon 2A into epsilon naught. And this force is attractive in nature because the force is negative. The magnitude of force is negative. Now, considering only the magnitude of force, so I'm not going to consider the sign. I'm not going to consider the negative sign. Since my force is attractive in nature, negative sign shows whether my force is attractive or repulsive. Okay. If it's positive, my force will be repulsive. If it's negative, if the force is negative, it is always attractive. So we can't apply Coulomb's law because, see, Hari Prasad, we know Coulomb's law is for only point charges. Remember, we discussed that Coulomb's law is only for point charges, but this is not a point charge, right? So we can't apply Coulomb's law here. Okay, okay, let's carry on. So considering only the magnitude of force to find the energy stored, now say if F is equals to Q square by 2A epsilon naught. So this is the magnitude of force with which the two plates are attracting or attracted. Now, if I have to, since there is just an attractive force, F, in order to keep the negative plate in position at a separation of distance D, I have to pull this negative plate, have to pull this negative plate to the suppression D such that, yes, I have to pull this negative plate to a suppression D such that there exists a capacitance. So to do this, I'm going to apply some external force F external. So how much would be my F external, guys? How much should be my F external? Nana F external ಎಷ್ಟಿರಬೇಕು? Yes. Come on, guys, answer, please. Everyone, try to answer. Come on, guys, come on. My external force applied should be equal to that of the magnitude of force, right? Yes. Is it should be equal to that of force with which it's attracting. Correct. Yaridu, Rajwal. Exactly. So my F external should be equals to F. F external should be equals to F, but in the opposite direction, right? Since my F is already negative, if I try to apply minus of minus, it will be again positive, right? So my F external is nothing but F in this direction, rightward direction. Now, what happens when I pull these? So why am I applying F again? If I apply more than F, what will happen? It may gain some kinetic energy, but I'm not interested with kinetic energy now. I'm just interested with its potential energy only. So when I pull this conductor or the plate, when I pull this parallel plate by a distance D by applying force F external, then what happens to this force? So what happens to this force, guys, when I bring it at the suppression of D? So the work done in keeping the negative plate at a suppression D will be stored as the potential energy, right? So this work done will be stored as potential energy inside this capacitor. Now, how much work have I done? So to calculate that, we have to check this. The work external done is nothing but force external times the suppression distance D. Okay. Now, since F external is conservative, so what can we say about conservative force, guys? So if my force is conservative in nature, what can I say about the external work done? So we had discussed this in our previous chapter, guys. Come on, tell me. What can we say about the external work done if my force external applied is conservative? No, Abhishek. Yes, charge is conserved. My force is conserved. So if my force is conserved, then the external work done can be considered as the change in potential energy, right? If my work done and the force, if the force is conserved, the external work done is stored as potential energy. And since the force external, since my F external is conserved, ಏನಾಗುತ್ತೆ? So I can say my work external is nothing but change in potential energy. Okay. The external work done will be nothing but the change in potential energy. Say initially it was at the separate, initially my negative charge plate was at zero suppression. Now when I have applied some force, I have applied some F external to move from this point 0 D is equal to 0 to the suppression of D. Okay, there exists some potential difference. Say here, my initial potential energy was 0, and the final potential will be some u. The final potential energy stored will be some u. Then the change in potential energy delta u is u minus 0. That is u, right? ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Yes, guys. Any doubts here? Why I took my external work done as change in potential energy? Exactly, Bhargav. Yes, the change in potential energy is then given as W external change. W external is nothing but the change in potential energy. Since my W external is nothing but force external into D, so I substitute the value of force external from my previous equation, that is q square by 2a times of epsilon naught into d will give me my external or potential energy. Okay, this gives my potential energy. Here, if I observe very carefully, what is my epsilon naught a by d? So if you see this very carefully, I have epsilon naught a into d, epsilon naught a into a divided by d here. So this is nothing but my capacitance of a parallel plate capacitor. So on rewriting this, I'll get the potential energy stored inside the capacitor is U is equals to half Q square by C. Okay, so this is the amount of energy stored inside the parallel plate capacitor. Okay, so yes, exactly, Jyoti. So this is nothing but the capacitance of my, this is nothing but the energy stored inside the parallel plate capacitor. Now, if I substitute, if I put Q as C into V, one more guys. So if I put my Q as C into V, what would I get Q square as? Then my Q square will be nothing but C square into V square. Oh, damn. C square into V square. Now, if I try to simplify this from here, what will be my value of energy stored? What will be the value of my energy stored? Then the energy value of my energy stored will be store u is equals to, so if I try to simplify here, that is half into c square v square by c. From here I can cancel my c or get energy stored inside the capacitor as half cv square. Okay, so this is the expression for energy stored inside a capacitor. Okay, so guys, understood how we derive the expression? Yes. Okay, cool guys, super awesome. So hope everyone have understood this. Any doubts in this, guys? Any doubt in any of the steps? Any doubts in any of the steps? Okay, I hope there is no doubt. If there is doubt, please ask right now. Okay, cool guys. Now, so this is the expression for energy stored inside the capacitor. Now, yes, since, yep, next we'll discuss about, okay, now, yeah, any doubts again, guys? I'm asking any doubts again? No doubts. Okay, then try to answer this question. If my capacitance, if my capacitance is 2 microfarads, if my capacitance is 2 microfarads and voltage applied is 100 volts, how much is my energy? Okay, Dhanush. Yes, Dhanush, I think that we had studied in our previous chapter only, right? Energy, so work done in bringing the charge dq. Yeah, this is, we can derive in multiple ways, Tanush. So we can derive the same expression using integration too. So there are many ways, multiple ways to derive an expression. You can follow any way. If you feel this is easy, you could follow this, or if you feel that that would be easy, you could follow that also. Okay, cool guys, come on, try to answer this question now. Everyone, please try to answer this question. So energy, we know that energy stored inside the capacitor is nothing but half CV square. So what is the expression energy stored? Okay, I'll write energy completely because we use E as electric field sometimes, most of the times, right? So I'll write energy, that is half into my C is 2 into 10 power minus 6 into V square, that is 100 into 100. So I'll get 2 and 2 cancels, 10 power minus 6 into 10 power plus 4. So this is nothing but 10 power minus 2 joules. Okay, always guys, please mention your SI units also. In your board exams, you have marks for that. Tejas correct. Tejas right answer. Krish Modi right answer. Yojita Reddy right answer. So Krish Modi is newtons per coulomb a correct unit for this energy stored. Okay, cool. So it should be joules. Okay, energy or work done. Energy is given by joules. Okay, guys. So yeah, I hope everyone have understood this. So also try to answer this question. A 900 microfarad, a picofarad capacitor is charged by 100 volts battery. So please try to first answer the first question only. And 100 volts. Say try to answer the first question only. So how much electrostatic energy is stored in the capacitor? So guys, you can answer this simply. Please answer in the chat box. Answer it directly. No, you can answer directly. So first question is a 900 picofarad capacitor. So what is given? C is 900 picofarads. So charged by a voltage of V is 100 volts. Then how much is the electrostatic energy stored? How much is the energy stored? Come on guys, answer this. Prajwal, Danush. Okay, I got your messages now. Few people have answered this. I got your answers now, guys. I don't know why it took so far. Oh no, okay. Okay, so guys, come on, try to answer this question. Okay, Danush. Cool. Yes, Danush, please check that. Danush, check your answer. Yeah. So what is the expression, guys? Again, what is the expression? We know energy is half into C into V square. Danush, I think you missed half somewhere. ಧನುಷ್ ಅವರೇ ನೋಡಿ ಅದು ಹಾಫ್ ಮಿಸ್ ಮಾಡಿದ್ದೀರಾ ಅನ್ಸುತ್ತೆ ಹೌದು ಇವಾಗ ಕರೆಕ್ಟ್ ನಾವು ಇಟ್ಸ್ ದ ರೈಟ್ ಆನ್ಸರ್ ಅನುಷಾ ಓಕೆ ಕೂಲ್ ತೇಜಸ್ ಕರೆಕ್ಟ್ ಹಿಯರ್ ಗೈಸ್ krish modi okay magnitude wise fine correct krish modi hariprasad correct okay guys cool so others please try to answer guys I don't know why many of them are not answering I have some trouble in launching polls also okay so let's check this. So the energy stored is given by half into C into V square. So what is my C? It's 900. So I'll substitute the values directly. Okay. So energy, we know that energy is nothing but half CV square. So half into 900 into 10. Pico is how much? 10 power minus 12 into V square. That is 10 power 4. I've directly wrote that. Now, if you try to simplify, you will get 450 into 10 power minus 12 into 10 power plus 4. Guys, try to simplify only the powers, you'll get the answer. Again, that is 450 into 10 power minus 12 into 10 power plus 4. How much is it? So you can get 450 into 10 power minus 8, like most of you had got. Or if you have to further simplify it, you can write as 4.5 into 10 power minus 6 joules. So the energy stored inside this capacitor is 4.5 into 10 power minus 6 joules. So hope many, yes, correct. Kaveri, okay, Chinmai, powers check ಮಾಡಿ, please check your powers. So 450 into 10 power minus 8 ಬರುತ್ತೆ, ನೀವು 45 ಕೊಟ್ಟಿದ್ದೀರಾ. Tejas, right? Kaveri, check with the powers. So magnitude wise, everyone have given me the right answer, but power wise, please be very careful. Yojita, correct answer. Hari Prasad, correct answer. Krish Modi, correct answer. So guys, those who have answered for first question, you can start with the second question. Hope everyone have understood the first question, guys. Any doubts in this? Doubt is like Haley. If you have any doubts, let me know. Any doubts in this, guys? Any doubts in this? Click on yes or no. If you have any doubts, click on yes. If there is no doubts, click on no. Please try to answer, reply. Okay, cool, no doubts. Thank you. So next question, guys. So I have the second part of the same question. Say, what does the second part say? The capacitor is disconnected from the battery. Now what happens? I have disconnected this capacitor from the battery and have connected another 900 picofarad capacitor. What is the electrostatic energy stored in this system? Now, what is the energy stored, guys? Come on, try to answer this. Say, I have the capacitor is now disconnected and it's another same value capacitor is introduced here. Now, if the same value capacitance is introduced, what happens to the charge? So, what happens? No, no, Modi, no, Krish. Please check your answer, Krish Modi. So, what happens to the electrostatic force? The battery is disconnected from the capacitor. So, what is the electrostatic energy stored by this? Come on, guys, try to answer this. Yes, correct, Rakesh. Rakesh, right answer. So Rakesh had given me the correct answer. Yes, correct, Dhanush. Oh. So in previous case, no object, take your answer. Hari Prasad, Krish Modi, check your answer. Hari Prasad, check your answer. No, there is no battery at all now, Hari Prasad. Hari Prasad, we have removed the battery. See, we have removed the battery and we have placed the new capacitor here. Okay. There is no battery at all. So you don't have to worry about the battery here. So try to find the answer. Abhishek, check your answer again. Dhanush, magnitude ಹೇಳಿ. Please tell me the magnitude. Yes, correct. Dhanush, your logic was correct. You did not give me the answer yet. Answer ಹೇಳಿ. Rakesh, right answer. Others, please try to answer, guys. Come on. See, Tejas, no. Check your answer, Tejas. I think Tejas had given me. Okay, cool. Tejas, check your answer again. Yes, Dhanush, exactly. Superb. Awesome. Correct answer. So, Tejas, check your answer again. Others, please try to answer. So there are many students here. So Priyanka, Rakesh, Spurti, Suprita, Sushmita, Swapna, Tejas, Tejaswini. Try to answer, guys. Come on. Prajwal, Prajwal, you are silent ಆಗೋಗಿದ್ದಾರೆ. Prajwal is being silent. Bhargav, no Bhargav. Check your answer again. So come on, guys. Dhanush, Harsha, Jyoti, Kaveri, Kavya, Kriti, Lohit, Manju, Megha, Nityashri, Pavan. Try to answer. Anusha, Chaitra, Chinmay, Dhanush, Harsha. Okay, Dhanush came the answer. Abhishek, Aishwarya, answer madak try ಮಾಡಿ, please guys, come on. Everyone here in YouTube, please try to answer. Prajwal, check your answer again. Krish Modi, check your answer. Bhargav, correct. Bhargav, check your magnitude once, na? No, no, Bhargav. First answer is also wrong. Second answer is also wrong. I think we solved the first question, right? ಯೂಸ್ ಮಾಡಿ ಚಿನ್ಮಯ್ ಹೌದು. You can use that also, Chinmay. See, guys, see the formula, or see, you have found the answer for the previous question, right? So what was the energy stored in the capacitor? That was initial case. In initial case, it was half CV square, right? So see, you have to check this way. Okay. In first case, say only my capacitor was present here. My capacitor and battery was connected to this. So when battery was connected, how much energy was stored in this capacitor initially? Listen, guys. Okay, Yojita correct, Rich Modi correct. So listen carefully. How much energy was stored in the first case? It was half into 900 into 10 power minus 12 into 10 power plus 4. Right, if you simplify this, you will get 450 into 10 power minus 8 joules. Okay, now, yeah, you got this much. Now, you are disconnecting the battery. This battery is no more available. So, all the energy which was stored inside this. Okay, cool, Bhargav. It's fine. So all the energy which was stored inside this capacitor in first case, this will be discharged. This charged capacitor will now act as a battery, and it will discharge. It will give out the charges to the second capacitor. So I have a charged capacitor now, and I'm connecting an uncharged capacitor to this charged capacitor. So I had C1 which was charged with 900 picofarad capacitance, and it was charged to some voltage. So energy stored in this capacitor was 450 into 10 power minus 8 joules. This much amount of energy was stored in first case. Now when I'm trying to discharge, how much will discharge? Cool, it's fine, Bhargav, thank you. Your answer is correct, Bhargav. It's fine, thank you. So guys, tell me how much will discharge? ಮೇಘ, ರಾಕೇಶ್ ಏನ್ ಹೇಳ್ತಿದ್ರಾ? No Mega, it won't be zero. Rakesh, no. Anusha, no. Rakesh, check your answer again. Yes, Tejas, correct answer. See, in this case, see, in if you can see in the image, so in first case, I had my energy, I had my capacitor, which was charged through a battery. So I had a battery, 100 volts battery. This battery charged my capacitor. In second case, this capacitor is charging the see, this is C1, and this C1 is now charged. Okay, my capacitor 1 is charged. Now this capacitor 1 is connected against the second capacitor which was uncharged. Okay, what happens when one charged capacitor is connected to an uncharged capacitor? So this charged capacitor behaves as a battery now, and it will give some it will discharge some charges on the second capacitor. How much will it discharge is my question. How much will it discharge? Prajwal, no, check your answer. Prajwal, is this answer for first question or second If you are mentioning the answer, please also mention the question number. Okay, first question or second question mention ಮಾಡಿ answer ಮಾಡಿ. See, in the second case, yes, up to attaining, both attain the equal charge. Correct, Dhanush. So the discharging happens up to such that, yes, okay, up to both of them it's the same voltage or same potential. Okay, that way I think you guys have answered. Yes. Now, how much energy will be stored in the second capacitor? How much energy will be discharged from first capacitor, or how much energy will be stored in the second capacitor? Not guys, tell me how much energy will be stored in the second capacitor. Energy stored in second capacitor. So what is the voltage which the second capacitor exhibits or experiences? How much voltage will the second capacitor get? Okay, correct, Rakesh. Exactly. Okay, I think you were telling this from last long time. So sorry, my chat box, since my network is very slow, I'm unable to access chat box properly. Yes, my voltage will be 50 volts. Then, since my capacitance was such that, so yeah, exactly. So, what was the initial energy stored in first capacitor? Energy in first capacitor was, yes, Chito, how much was my energy stored in first capacitor? Yes, Krish Modi. Total energy should be same. Energy is always conserved. Okay. So, what was the energy stored in first capacitor? It was 4.5 into 10 power minus 6 joules, right? So when I connect the second capacitor, half of its energy, half of energy from first capacitor will be given to second capacitor, will be given to second capacitor. So how much energy will be stored in second capacitor? Yes, half of the total. So how much energy will be stored in second capacitor? Energy in second capacitor is, just to really mega check your answer. Don't round off, guys. Yes, Krish Modi. Yes, energy in the both capacitor summation will be 450 into 10 power minus 8. So one capacitor will be having a total energy of 2.25 into 10 power minus 6 joules. So half of this amount of energy will be stored in the second capacitor. Okay. See here, many will say now. So mega, I think mega got confused here. How the mega? CNI2. So what happened there? My is okay. See, when you're trying to calculate half CV square, you have to calculate the capacitance also. New capacitance would be how much? No, Rapa. So initially I had a capacitor which was charged using a battery. The total voltage inside the capacitor is 100 volts with the capacitor C1. Now there will be a second capacitor which will be connected across this first capacitor. Okay, across the charged capacitor, I have an uncharged capacitor connected. So, how much amount of charges will flow from first capacitor to second capacitor? In question only, they have mentioned it will be half of the charge on each plate, right? So, Q by 2 amount of charge will stay here, and Q by 2 amount of charge will go here. So, how much will be the new capacitance in both conditions? How much will be the new capacitance? Mega, Anusha, try to reply. Yes, correct, Bhargav. Correct, Krish Modi. So how much will be the new capacitance for this case and this case? ಎಷ್ಟಿರುತ್ತೆ? Anusha, I hope you are following. See, the amount of charge reduced to half, then capacitance will be reduced to half of its initial capacitance, right? The capacitance will be reduced to half of its initial capacitance. So half of energy stored. So half of energy stored ಎಷ್ಟಿರುತ್ತೆ? Half of energy. So half of energy of first capacitance will flow to the second capacitor. So energy stored in second capacitor will be half of energy stored in first capacitor. ಎಷ್ಟದು? How much is that? Yes. Okay, then calculate using that. Yes. So you'll be getting QV by 4. QV by 4, right? You will be getting QV by 4. Dhanush. Q into V by 4 in this case. So that is nothing but half of total energy, right? So the energy stored in second capacitor will be half of the energy stored in first capacitor. So that is 2.25 into 10 power minus 6 joules. So guys, anyone have any other doubts in this? So if you want me to explain again, let me know. So listen guys, so total energy stored in new capacitor will be half of C into V, right? Or half of, yeah, half of C into V. What is my C here? So I know C into V, half of C V square. So my new capacitance will be how much? We can go in the other way also, or we'll go like this, half into Q by Q square by 2C, right? If I'm not wrong, this was the expression. So if you check, my charge on individual capacitance is Q by 2 whole square upon C. So if you try to simplify this, you'll get 1 by 4 times of QV by 2, so QV by 4. So that is nothing but half of energy. Okay. So half of total energy is nothing but 4.5. So that is nothing but 4.5 by 2 into 10 power minus 6 joules. So energy stored in second capacitor will be 2.25 into 10 power minus 6 joules. Okay. So guys, any doubts in this, please click on yes if you have any doubts. Let me know if you have any doubts. I don't know. Okay, there's no doubts. Cool guys, then we'll try to check the other concepts in next class. Don't know, today there was lots of internet connectivity issue. I'll try to check that this doesn't happen again. So let us check for next class. So in the next class, we'll be learning about energy density, guys. We'll be learning about the energy density. So yeah, we'll be learning about the potential energy stored in the existing field. Okay, cool guys. So come prepared to this class. So we'll be learning about energy density. Then we'll be learning about the expression for energy density. Once energy density is done, we'll be learning about, yeah, we'll solve few problems and we'll learn how capacitors work in our day-to-day life. So we'll learn about polarization happening in case of capacitor. So also we'll learn how capacitor actually works, how it stores energy. Then we'll learn about the capacitor and its uses, capacitor as a device. Then we'll learn about combination of capacitors in next class. So please come prepared to the next class. Yes. So yeah, there was some internet issue over today's class. So we'll check that it won't happen again. Okay, guys. Cool. Then we'll meet again in our next class. Okay. So everyone, please try to give the feedback and thank you. So guys, hope yeah everyone understood. So YouTubers, if you have any doubts, please let me know. Again, guys, if you have any doubts, yeah, let me know. Okay, everyone, please try to give your feedback and you could leave the class once you have given the feedback. Guys, please give the teachers feedback. Okay, guys. So yeah, bye, guys. Bye. We'll check again tomorrow. Okay, thank you for being here. Bye.